Right. As we're starting now, we are discussing today what we call the modified Euler. And now, as we discuss the modified Euler, we need to note that or what we call Euler's method. Right. Euler's method is a single step method. Is a single step method. Okay, this is very important for us to understand. Why is it necessary for us to sort of use the modified version of the Euler formula? Right. So now here we can say it is the modified Euler that we're talking about. And the modified Euler, right, so the modified Euler's method. Yeah, didn't just change here. Modified Euler's method. Right, modified Euler's method in full, we say that. Right, so we'll have a discussion to look at a couple of examples. That is the plan for today. Right, the modified Euler's method is a multi-step. It's a multi-step method. Okay, so moreover, I want to make mention of the fact that the predictor corrector method is also known as the modified Euler method or Euler's method. Okay. All right, we take note of these here. Now, sometimes we shall be just calling it the modified Euler method and just Euler's method. It's common in literature. Okay, I want to make mention of a couple of things before we move on. In the Euler method, it's a point. Right, in the Euler method, we're just having a discussion about the distinction here. In the Euler method, or in Euler's method, the tangent is drawn at a point. And slope is calculated for a given step size. All right, for a given step size. So in other words, in the Euler method, the tangent is drawn at a point and slope is calculated for a given step size. As a consequence, we then say thus. Yes, please. This method. I'm in class now. This method. Okay, okay. I'm in class now. Okay, I'll talk to you. All right. This works best with linear functions. With linear functions. But for other cases, um, there remains a truncation error. Okay, so there remains what you call a truncation error. There remains what you call a truncation error. All right. So the Euler method, or in the Euler method, the tangent is drawn at a point and slope is calculated for a given step size. Thus, this method works best with linear functions. It works best, obviously, with linear functions. But for other cases, there remains what you call a truncation error. Now, the truncation error that is experienced is therefore now to solve this problem. Right, to solve.
Hello?
Yes, please.
What is a truncation error?
The truncation error becomes the rounding off error. It becomes a rounding off error in the nonlinear cases. But obviously, we're going to elaborate on the difference between the modified and the Euler method, and we shall calculate the truncation error to demonstrate how it's calculated. Okay, so it's basically just the rounding off error in calculations. Right, so to solve this problem of the truncation error, to solve this problem, the modified Euler method is introduced. Modified Euler method. Right. It's common in literature to just call it Euler method, modified Euler method, than just Euler's method, like Taylor method than Taylor's method. So to solve this problem, the modified Euler method is introduced. So in other words, the actual distinction between the results obtained by using the Euler method and the modified Euler, you're able to see the discrepancy, and hence that is the truncation error that is seen if one gets an estimated value using the Euler method and another value at the same point using the modified Euler, and the difference is the error, is the truncation error. Okay, so to solve this problem of the truncation error, why are we speaking about these errors? Because we know because most of these differential equations, we can find the exact value, the exact solutions, and we can get the exact values. Obviously, for some, it's difficult to get the exact values, but in many instances, we give examples where we can find the exact values and compare with a method, the value obtained using the Euler. You really can see the discrepancy between even the exact and value of a function and the value of the function using any of these methods here. Right, so to solve this problem, the modified Euler is introduced. Okay, I want to mention more. Okay. In the modified Euler, Okay, there's more. We need to just say, yeah, we're gonna just do calculations here, but I'm just elaborating. But in the modified Euler method, a point right in the modified Euler method. Okay, I want to say in the modified Euler method because I'm drawing a comparison between the modified and the Euler. Right, in the modified Euler method, instead, or rather instead of a point, the arithmetic average, okay, we shall see the average we're talking about in the formula. We saw it last time, but yeah, we shall have a different view today. So in the modified Euler method, instead of a point, the arithmetic average of the slope over an interval xi plus 1 is used. Right, so in the modified Euler, instead of what? Instead of a point, the arithmetic average is a arithmetic average of the slope over an interval is used, and we shall just analyze that. Okay, yeah, we are continuing now, looking at how best we can describe certain things, but yeah. Okay, we're gonna say that we discuss so the easiest way today. Right, the easiest way to solve, that's okay, to solve the problems. We discuss the easiest way to solve the problems and construct the, there's a table we're going to construct, and construct the table in an effective manner. All right, so we're going to construct a table for the modified Euler. How do we construct this table? So this table we're going to construct has what we call the predicted values versus the corrected values. Okay, I'm mentioning this because it is expected that in the exam this is followed. So one would have, for example, what is all this here? You'd realize that here there is clearly an x, this is a y, there is an f, x, I, y, I, right. And then there's going to be the predicted the predictor value. There's going to be the predictor value. Okay, just a sec. Hello, Kulani. All right. Yes. Yes, yes. I'm in class now. Can I get back to you after my class? Yes. Can I get back to you after my class? Is it Kulani? Yes, is it Kulani? Yes. Wilson, yeah, Wilson, huh? Yeah, yeah, definitely. After my class, I'm gonna send you because I'm in class now. Yeah, that's fine. That's fine. Okay, thanks. All right. Right. So there is yi plus 1c. Okay, let me just try to draw it at the table. Please forgive me. I just want to demonstrate the table here. Right. Okay. This is the sort of table we learn. In this table is just gonna have take this format and when I have a couple of divisions, right? And yeah, I'm just gonna be quite quick because this is just a rough idea of what we're gonna be doing. Right, so this table is gonna have a couple of columns, like I'm gonna have a vertical line here. And then this one is there's gonna be in the middle. So we're gonna cut here. So we're gonna have the predictor values on one side and we're gonna have the corrector values on the other. And then we're gonna have the those corrector values there. And then we're gonna have the rest of these here. Right, we're gonna have the rest of this here. Okay, so yeah, the predictor values and the corrector values are put together, and then you're gonna have the corrected values put together like so. And then right. Right, so you're gonna have quickly that. Yeah. An average, so we're gonna draw the table like that, but we're gonna do a couple of problems now. We did the table I think for the Euler, but now we're gonna be doing it for the current modified Euler. Okay, so yeah, just a note there. Right, let's continue quickly, please. There are a couple of things that I'm going to look at, for instance, in relation to these, the idea of the predictor and corrector methods and how these two methods are interrelated, but also how these methods, so in other words, we're going to have the predictor values where we have the x, the y, the f of x, the f xi, yi, the predictor value, the xi plus 1, which becomes the next one. We're going to see how that works, etc. Okay, obviously we're going to see better with examples. Let's mention the notion of the predictor and the corrector methods here. In the predictor, corrector method, or okay, so we sometimes call it the predictor corrector method, but it is certainly the modified Euler as well. So we use these words very interchangeably here. Right, predictor corrector method or the Euler method, because the modified Euler, excuse. So the modified Euler has the predictor equation and the corrector equation. So in the modified Euler you have a two set of equations. Right. In other words, if you have a differential equation like this, so because there's a y and an x, you start with the x and then the y because there's an x and a y. But obviously always we have these are initial values, so there is a value given where there's y of x0 equals some y0 there. Right, so there is the predictor. So the predictor is y. Okay, we're gonna use y. You can use, we used the w last time, but it's the same thing. Right, so we have yi plus 1 to the p plus h f of xi yi. Right, and then also this is the predictor formula that we're going to use when we are doing the predictor correct method in the modified Euler. But this predictor is the Euler method, this. So, but now you also have the corrector. So the corrector equation, right? So this one is the one just described now in what's in the paragraph above I wrote, where we said that it takes the average. So the corrector, how is the corrector now different? Because modified means you just have the predictor and the corrector. So now the corrector is yi plus, then you have h over 2, then you have f of xi yi plus f of xi plus 1. And then we put here yi plus 1 predictor. Okay, so these two, we did this last time, but we're using the W's, but I just decided today that to use this, it's a bit more convenient for what I want to do today. So, but in the relation looked at last time, we just took this formula and we put it here. But now today we decided to just separate and have the predictor aside and the corrector aside. So after we got the predictor, then we just plug it in there and then get the arithmetic average. Okay, now let us look at these in detail, but there is a remark that I want to give here. Right, so there is a remark I want to give. So the notion of what we call the modified Euler, the modified Euler method is an example. Okay, so we'll learn how these methods are related to each other. So the modified Euler method is an example of the Runge-Kute, of second order. Of the Runge-Kute of second order method. Okay, we are saying the modified Euler is just an example of Runge-Kute of second order. Okay, when I see how the modified Euler is just Runge-Kute of order 2, because we have Runge-Kute of multiple orders. Of order 1, what we call Runge-Kute of order 1 is called Euler. Runge-Kute of order 2 is the modified Euler. And then there's Runge-Kute of order 3 and order 4, which we're going to discuss. So the first two orders is the Euler is order 1. So in other words, this is what we called Euler, the Euler method. And then this one is what the corrector is what we call the modified Euler. And then obviously we're going to look at examples. I'm just stating the formulas here in the form we're going to use today. But now if one speaks of the modified Euler, is just a Runge-Kutta of second order method. All right. Now, let's just see what is this here. Okay, we have seen that I'm going to mention this again. I want to speak about the Runge-Kutta of order 2, because today we're going to be looking at calculations of the modified Euler. But this Runge-Kutta is part of this, because the corrector so you have I plus 1c plus h over 2 into fxi yi plus, then you have f of xi like this. Then you have, okay, this is exactly the same as what you wrote for the modified Euler using the w's, but today we're using y's. And this is sort of a version that is more compact. Right, so the corrector is like this. But how is this? But now we can decide to write the corrector differently. Like we can say yi plus 1 is the same as yi plus k1, k2 out of 2. Okay, the notion of the k's is what we study when we use the Runge-Kutta. And then where k1 is hf xiyi. Okay, there's k2. K2 is this one. So this one is k1. And then k2 is this one, but you just allow the h to go in if you multiply here. And then you have f of xi plus 1 yi plus 1 for the predictor. So yeah, so in other words, this one we call the Runge-Kutta of order 2 when we have the two k's. So Runge-Kutta of order 2 is just the corrector that is available in the modified Euler version. Okay, but yeah, the predictor and corrector methods here is discussed in the modified Euler case. But I must indicate, therefore, that this is quite the predictor and corrector also are available in many other, like in the Adams-Moulton. So it's something you need to be aware of. Okay, let's give an example, please. Let's start calculating here. We've just been sort of giving stories here. Okay, an example. Okay, today we're going to look at a wide range of examples, but first, example 1. Okay, using the modified Euler method, obtain a solution of the equation. Right, the equation is dy dx xy in the range right in the range 1.4 with together with H equals 0.1. All right, so if we're saying using the modified Euler method, obtain a solution of the equation these. Okay, so we just need to use the modified Euler and we get the solution to this with the predictor and corrector computations. Just one correction at this point, and then we shall do multiple corrections. So now the question is, what is the answer to this using the modified Euler? We look at the solution to this. Right. Right, looking at the solution to this, we proceed as follows.
Hello?
Yes, please.
Do I have to memorize these formulas?
Yes, because in the exam, like in November, they did not give this formula. They did not give the formulas for the modified Euler. So many times they do not give the formulas. So you need to really remember them because yeah, in November they did not give these particular formulas for the modified Euler, the predictor and the corrector. That is why I'm stating them in the way I'm stating them now, because I feel that it's much easier to remember them this way. And surely they don't give them. Right, they don't. Except in rare instances when they give. Like in the Adams-Moulton case, they give in the Adams-Moulton case, but we saw in the exam that the Taylor was not given its formula. The Euler and the modified Euler were not given. The central difference formula or the finite difference or the method of finite differences as well, those formulas were largely not given. Okay, so yeah, you need to just remember them. Right, let's look at the solution to these. If you're just saying dy dx equals xy in the range 1 to 1.4, y to 1 equals 5, h is only 0.1, how do we find the answer in the range? Okay, if they ask the question like this, what do they want here? What the examiner wants here is actually to say, why at this? Because they've given y at 1, but they want y at 1.4. And effectively, the examiner is saying, given everything here, find the estimate, the approximate value of these here. Okay, let's find the approximate value of these. But this one is an easy equation. You can even find the most exact, because this is a separable differential equation from first year, but it's not of interest at the moment. So what is y at 1.4 using the modified Euler? Right, we continue to find the estimate. Right, so given that, so part of the solution, right, we know to what has been given, we first write down the question. It's standard in mathematics to say, given that dy dx is actually xy, that is the question, but you also given that y at 1 is 5, that is the initial value. Thus, using this for this course, if you given the differential equation, it means that f at x and y is xy. But it means that y at this is h, f at xi, yi. It means the predictor is this, and also it means the corrector is. So always when you're using the modified Euler, we do the predictor and the corrector. But in the exam, they asked for 2 corrections. So you can use the corrector twice. So you can use the corrector and then use it again. Right, so you have fxi yi plus fxi plus 1, and then you have yi plus 1p, like this. Okay, so now the question is, in this problem, what do we do? So first we're going to do the predictor, and then we shall do the corrector at each step, and then we shall draw the table. I think that is the easiest way to do this. Yeah, we shall organize them at the end. It's okay. All right, but yeah, I want to just show the steps. So first things first, we shall say x0 is, okay, first you give the x, x0. x0 is 1, and then y0 is 5. So x0 is 1, and y0 is 5. And then we need to also do f x0, y0. According to that formula is xy. So f of x and y is xy. So you just multiply them. So
Hello?
yes, please.
How did you get y0 is equal to 5? Isn't it y1?
Okay, that's a good question, isn't it? Y1. Okay, always the original values, the initial values are at 0 at the origin. So this is x0 and this is y0. Okay, so always the given values are x0. So in other words, what we're effectively saying, always if you're given an initial value, it means that x0 is exactly what this is, which is 1, but x0 always goes with y0, which is 5. Okay, so which is exactly this. Then now you find the f0 y0, which is x0 y0, which is 5. And then at this point, you need to find the predictor. Always you find the predictor first, and then you can find the corrector afterwards. Let's find the predictor. So the predictor, what is the formula for the predictor? The predictor is this one. It is yi plus 1, which is yi plus h f of xi yi, like this. Okay, so this is the predictor. But now we're going to use it to get what we want. So in other words, what are we actually going to get at this point? Because you have already got x0, y0. So in other words, if you are to get, for instance, a y1 here. Okay, if you get a y1 here, this is going to be y0 because you already have a y0. So the next thing you need to get is a y1, but for the predictor and the corrector. So which means that we have f x0, y0. What is y0? 5. Okay. H. What is h here? Is 0.1. Here, 0.1. So you're going to use it. 0.1 times f0, y0. You have 5. And this is exactly 5.5 because this one is 0.5 plus 5, which is 5.5. Okay. Okay, I want you to pay particular attention to these because it's very, very important. But it is evaluating the function at x0, y0, x0, y0. Now, okay, we're done with the predictor. Once you do this, you are done with the predictor. So this is the predictor calculation. So you must sort of repeat these steps. So you start with the predictor and you go through these steps, and then the same is done to the corrector. Let's do the corrector. Okay, after I've done the corrector and the predictor, and then we shall do the table. So if x0 is this, the corrector is always at the next step, because what you have, for example, is that it is computed at yi plus 1. It is most certainly always computed at yi plus 1. But I'm going to say more to this. It also has xi plus 1, and it has the predictor value put here as well. So let's just do the calculation that will be next after this predictor, because it's always predictor, corrector, until we get the answer. And yeah, we shall state when we shall say we have got the answer to this. So now we come here. Yeah. Then we shall go here and say we're interested in x1. What is x1? Okay, because x0 is 1 and h is 0.1. So you add here, so it's going to be 1.1. Now, if it's 1.1, then what is the, then we do the same thing like here. We do the same thing like here. Okay. Okay, yeah, let's do, I'm going to do like this. But we've already got this y. So the x1 goes with y1 predictor, and it's 5.5. Okay, so it's always the x and the y, but the corresponding y. And then now we're going to do the product. Okay, so if you have the xi plus 1, yi plus 1, so we need to just put these ones. So it's going to be like x1, then y1 predictor. And then it is, according to this formula, f of x and y is the same as x1, y1p, which is x1, 1.1. Put this one here. And then y1 predictor is 5.5. Okay, we're just going to summarize this now in a table. And then if you do this, you're getting 6.05. And then we are now having the next thing, which is the corrector, because we did the predictor here. Here we're doing the corrector, so we can do the corrector now. So what is the corrector? Is the yi plus 1 corrector, which is yi plus, then you have h over 2 into f of xi yi plus f of xi plus 1, yi plus 1, predictor. Like so. Now, if this is the corrector. So at this point, what is y1 corrector? So it happens when I is 0. So you have y1 corrector is equal to y0 plus. So y1 corrector is y0 plus h over 2. Okay, we're gonna summarize this in a table because now we're just doing these calculations and like what's happening here. Then this is x0, y0. F of x0, y0 plus, right? And then here, this one is going to be x1 because when I is 0 here, it's going to be x1. Yes, it's going to be x1. Yeah, okay. x1, then y1 predictor. y1 predictor, then you close. So, which means that you have y1. Then what is y0? Right, obviously we have got exactly what y0 is because y0 is 5. H is 0.1, 2, oops. Right, so yeah, just making the H clear because it doesn't look like a clear symbol. And then here, this one, f x0, y0, we've already got it. F x0, y0 is 5. Plus, then you have f x1, y1p. You've already got this one, is 6.05. And then you have y1, and then you need to just to do the calculation here. Okay, if we do these, we must be able to get 5.5525. I need to check these, but that's what I expected to work out to. Okay, so we get that one. As I said, I'm just cross-checking if that is the correct answer. But yeah, and as far as it's 0.1, you divide it by 2, and then you have 5 plus, and then 6.05, and you close. And then you have, it's exactly that. Okay, so we've got the corrector. And then we are done for the first part. What is the first part? Well, the first part is the computation that corresponds with the x0, y0 part. Because from the x0, y0, we must get the predictor and the corrector immediately afterwards. And then now we shall go and do the predictor and the corrector at the next step. What is the next step? It's 1.1, we must do the predictor there until we are able to do the predictor at 1.4, because we must do this up to 1.4. Okay, let's do the predictor now again. So, but at the right, I need white. Right, so for example, at x1, which is 1.1, because x0 is 1, but h is 0.1. So just add the h to x0. Okay. With this said, then what next do we do? Like we did exactly the same thing before. The question becomes, because we're doing the predictor now, so you must do the next value. Okay, the question is, what is the next value of y, so that you can be able to do the rest of the calculations. Okay, so it is clear that at this point, y1 is this one of the corrector, 5.5525. Okay, this is the y we use, but now at x1, and then we're going to do the predictor here. And at this point, we got x1 and y1. We're dealing with the predictor again at this point. So we must do now f of x1, y1. Okay, according to that formula of the differential equation is the product, so that you have 1.1 into 5.5525, and therefore what is the product of this? And the product must be 6.1078. Okay, where are we now? Because we're using this model. So we are here. And then now after we got the everything. So in other words, we are getting the x, the y, and this part, h is known, and then we can do the predictor. So now let's do the predictor now, because we got everything. So the predictor now will become, first things first, we note that the predictor has its formula, which I'm just going to squeeze here, and then we're just going to, okay, the predictor is nothing other than what we call the Euler formula, xi, yi. Okay, and then you have this one. So which means, therefore, you have y0. Nope. Right, we're going to do the appropriate step here. Because obviously we can see that if we have got these, then we must get the next step. So because we got y1 predictor, we must get y2 predictor. So which means we're going to get y2 predictor. And then if we get y2 here, y2 occurs at I equals 1. So you have this. So this is x1, y1. Okay. So what is y1? Right, so we can see clearly what y1 is. We've already got that, and we've already got the product, etc. So we're just going to plug in everything. So it's 5525. Okay, for this question, h is 0.1. And then we've already got the product, which is 6.1078. And then we get the answer. And the answer here is this one. It is exactly 6.1633. Okay, I must believe that that is the correct answer, but I must just check this, because when I check this at some point when I watch this video, I realize that it is not check this. 5525 plus 0.1 times 6.1078. Okay, so you have this, and yeah, it's exactly that. So obviously you can write it as 6.1632833. It's okay. But you can write it as 6.16328. Okay, so what have we got? That is exactly the predictor. Value y2, and then you must get the corrector y2 as well. And then, yeah, this is not very long because we just have 2 more steps afterwards, and then we shall draw the table. Okay, so now the next thing is now we are done with the predictor. Once you get the y2p, and then we must get y2c, if one likes to put it that way. Corrector, next step. So let's do the corrector now. Right, so we're doing the corrector in the same way like we did before. What is the difference between these? So we must just get, because this was x1, y1, because it was going with y1, p. But now we're gonna do, we are dealing with y2p, so we must get x2 and then use y2 here. Okay, so we're set. So we need to get x2. What is x2? Right, x2 is, what is x1? We said x1 is 1.1, but to get x2, then we add this, which is 1.2. But we have y2 predictor, which we have got, which is exactly this one, 6.16328. You can write 6.1633. Okay, we've already got this here, the y2x2. Okay, because we must look at this formula. We've already got the, like, the x2, y2, and then now we must multiply them. Why? Because that is the original differential equation. Yes, we must multiply them. So because we must use the original differential equation, so we're going to use f of x2, y2p. And then this says multiply them. So you have x2, y2p. x2 is 1.2. y2p is 6.1633. What is the answer? Okay. Just gonna do this one now. Mm-hmm. 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 Yeah. Right. I'm getting 7 point. Gonna check this. 7.3959. Okay. 1.2 times 6.1633. Yeah, it's exactly that. 39596. Okay. And then this is what we have. So let's just check how far. Okay, so for the corrector part, we've already got this product now. And then we just use this formula. Okay, so we must use the corrector formula. So what is the corrector formula? Is yi p. Yi plus h over 2. This. Xi plus 1. Yi plus 1p, like this. Ah, All right. So you have this. Okay, that's fine. Now, with this, then we must get y2 because we got y2c, we got y2p, we must get y2 of the corrector. So y2 of the corrector. What is y2 of the corrector? Okay, y2 occurs when I is 1 here, so that you have 1. Okay, and then this one, 2, 2p. Okay, we have this. And then what is y2c? Right, it's exactly y1. What is y1? Like we saw before here in the corrector, that the y0 was what was there in the beginning. So, but we got a y1 here. Right, and this y1, that's fine, is what we got before in the predictor. And it is in right. It's what we got before in the predictor, yeah? Yes. And now it is exactly this one. See? Wait a minute. This is y2. Yeah, this is y2 corrector. So, okay, we've already got the y2p, but what is y1? Is this one? Yes. You've already got the y1, which is exactly that. And it's the same y1 we used. Like, in this case, the same y0 we used in both the corrector and the predictor. We use the same y0, so we're going to use the same y1. And then now the y1 here is what? Okay, you can see that the y0, yeah, is that. So what is the y1 we used in the predictor? Is 5 point that, which is exactly this. So they're going to use the same 5.5525, 5.5525 plus. Okay, we're going to tabulate all these things because I know they sound so mixed up. H is 0.1, you divide by 2. Okay, this is like x1. So f of x1, y1 is exactly what we got. So f of x1, y1 is exactly what we got, and it is exactly this, which is 6.1078. 6.1078 plus. Okay, now we have f of this. We got this one here, which is 7.39596. Okay, yeah, let me just do this carefully. On the calculator, need to just verify what this is going to work out to. 5.5525 plus 0.1 divided by 2, 6.1078 plus 7.39596. You close. Good. Is the correct answer because it gives us 6.227688. So it can be approximated to 2277. Okay, I did this before, but I'm doing it again now. But now I'm trying to show you a bit more steps than I did. But we're gonna do we're gonna draw the table next just to conclude because I drew the table so I can see the values correspond there, but I'm just verifying now. Let's do the predictor. Next. Right, so we're gonna do the predictor here. So when we're doing the predictor right now, when I do the predictor, the next step. What is the next step? Because this one was at x2. So we must do everything now at x3. Okay. Let's do everything now at x3. Yes. So, all right. That's fine. Just don't want these things to get mixed up. Right. If you're doing it x3, we've already got x2. Sometimes it's easier to use the method we used. H. Okay, yeah. So that you don't forget and you need to you don't go back all the time. But I mean, you can just say xi like we used before and then say h times I. So if you say x3, then you just take the h and you multiply by 3. Right, but you'll have to add the the original x0 because it's not 0 here. You add it. Always you add the x0 because it's not 0, but yeah, in the problem we did it was 0. So yeah, but here it's not 0, so it's going to have an effect. So it's 1. So you must add it. All right, if you add that, what you're getting therefore is 1.3. Okay, it is the correct x3 value. Now, now what do we do next? We must get the corresponding y. So it means that we must get y3. The question is, what is y3? Okay. Y3 is for the predictor. So let's write the formula for the predictor, please. yi plus 1 predictor is yi plus hf xiyi. So what is y3 from this? Okay, if you're doing the predictor, I want to show something. If you're doing the predictor, this is exactly what we did in the beginning. And we use the predictor relations to get the next y value, and we got the products of, we used the differential equation, okay, to just, but yeah, this is the formula in the end. The tangent, one way to see why we're doing all these things can be to say, if you have y0, the next thing to get is y1, and you can just write the formula and gather the information you will need to plug to substitute into this. Okay, so it's another way to think of this. So obviously at this point we need y3. So what is y3? Y3 predictor is, okay, y3 is going to be y2 plus h is 0.1 f of x. So if this is y3, then it occurs at 2 at I equals 2. So this is 2, 2. Right, so if this is y3, what would y2 be? And what would the rest of these be? F of x2, y2. Right, so let us just compute that. So y2 is going to be exactly what we have. What is y2? It's this one. It's 6 point that. 6.2277. 6.2277 plus 0.1. Okay, now you have f of x2, y2. Okay, so what is f of x2, y2? Okay, so obviously, what is x2? X2 is 1.2. So this you can see x2, y2, which is 6.2277 plus 0.1. X2 is 1.2. And then the y2 is 6.7777, which is the same as what? Just 6.2277 plus 0.1 times 1.2 times 6.2277. Okay. Okay, there's something I'm just checking, please. Just a sec. 6.2277 plus 0.1 times 1.2 times 6.2277. Okay, right. Something I need to just cross check here. Yes, that is the correct answer. That is exactly the correct answer. Just to see. Okay, because it means that Y3 predictor is 6 point. Okay. Right, so it is 6 point. Okay, because I have my own records of this. 6.97, but I'm just trying to elaborate a little bit. 5024. Okay, so this is, so, but yeah, we're going to round it off in the table. Going to round it off to 6.975, like this. Okay. Right. But I want to make mention of something here, that this one, I want us to write it down. I want to write this one down. This f of x2, y2, see, right. F of x2, y2, because you're going to put it in the table. According to the formula is x2, y2, but this is x2, y2. Okay, the table is going to summarize everything. What is x2, y2? Okay, we've seen that. Yeah, let me just write it properly. Substitute into the arguments of the function. So that is going to be, for instance, just 1.2 for x, and the y is 6.2277, and then 1.2 together with 6.2277, and then you get the answer. One point two times 6.2277. Well done. Correct answer. So this one is going to be 7.47324, which is f of 1.2, 6.2277. Okay, note this answer because is going to be used, this answer to in the table, and we need these. We always need the product to use, so we need every single bit of thing. Okay, we are done with the predictor, and then we must do the corrector for x3, and then yeah, corrector. Right, so the next thing we're doing now is the corrector. So okay, right, so the corrector, like we said before, okay, the best thing I think is to always have a strategy to do this. Just write the formula first of the corrector. I think that it makes things way too easy. Otherwise, sometimes you get a lot of this information juggled up and mixed up. Okay, just write the formula first of the corrector because you already know it. After I've written this formula, then we'll see what we need to substitute into the formula so that we gather it from the previous calculations. So you have x I plus 1, because then you get a little bit mixed up here. Then you're looking for this, you're looking for that. Okay, now you have this. But we said because now we had got the x3 here, we're looking for the y3 for the corrector. Y3 corrector. Y3 corrector. So y3 means that it occurs when I is 2, h over 2, when I is 2. When I is 2, this is going to be 3. 3. Okay, it's going to be 3. Like this. Oh, yes. When I is 2, this is going to be 3, but this is going to be 2. So they're like different. Okay. Now, what do we need? We need to gather everything here, and we need to look at what is missing and what's not. Okay. Do we have x3, y3 for the predictor? For example, let's just check. Yes. But did we multiply them? The x3 and y3? No, we did not multiply them, so we need to multiply them now. For the sake of this part of the formula, then we're going to multiply them. So we need to use the differential equation to get x3, y3 predictor, which we're going to use in the corrector formula. What is x3? 1.3. What is the predictor? It's 6.975. 6.975. Okay, you multiply these, and if you multiply them, okay, I need to just use this. 1.3 times 6.975. Okay, so this one is 9.0675. Right, so we got this one. And then now we just need also the fx2y2. It's like that one got. Yeah, fx2y2 is this one, which is the 7 point that. So fx2y2 fx2y2 is 7.47. 7.47. Then you have 3 to 4. Okay, so we got this fx2y2. We got this one. We have h is 0.1. And then we have also y2. What did you get y2 to be? This one. It's 6.2277. 6.2277. Okay, yeah. It's easy to get mixed up here. So okay, we got everything now, and we can get y3 of the thing of the corrector. So which means that we have y3 corrector. Excuse me, y3 corrector. Right. So having y3 corrector is the same as what? Is the same as y2 plus h over 2, and then you have f of x2 y2 plus f of x3 y3p predicted, which means we can plug in everything here. Okay, we got y2 to be 6.2277. 0.1. Okay, what is this one? fx2y2. 7.4734. fx3y3. 9.0675. Okay, like this. And then we close. Let's see what y3 corrector is going to be. y3, I mean. Let's see what this is going to be. Okay, just using my calculator quickly because I just need to verify that we're getting the correct answers here. 6.2277 plus 0.1, you divide by 2, then you multiply by 7.4734 plus 9.0675. Okay, what is the answer? 7.05. 45. Okay, correct answer. Correct answer. Okay. This means this y3 is evaluated at 1.3, which is the corrector. Okay, the next thing is to do the last one, and then I'm going to give an exercise. Okay, exercises. There are many. I have lots of them that I've worked through. Okay, let's look at the next step, which is y4, because we did x3 predicted, then we're going to do x4 predicted. Predictor. Right. So the predictor, we first do x4. What is x4? Like we said already, is always x0 plus h times 4 in case. Okay, obviously we did xi is the formula we use. So if it's x4, so that you don't have to look back all the time, x0 is 1, and then h is 0.1, and then I is 4. Okay, it's not xi, but it's I, excuse me. Okay, so it's always hi. So yeah, when I is 4, you have this. Right, so which means therefore here is 1.4. All right. Right, we have this. Then when we have this, then we need the formula for the predictor. What is it? And then now we're going to just deal with that formula. Okay, formula for the predictor, general formula is yi plus. Okay, is a strategy that always you write the formula first, and then you can just gather the information you need to use the formula to evaluate. So you have h f of xi yi. What is the next thing that you're going to get? Okay, we want to get y4 because you got y3. So if you're getting y4 here, p, it means I is 3. Okay. All right. So all right. So we have this. Okay. Yeah, we're continuing, please. The question becomes, where do we get the rest of the things that we need? Right. We've seen we got the y3 and we got the x3, so we can compute and say thus we have y4 predictor is y3, which is exactly this one. Take exactly the preceding corrector value, 0.54745. Okay, the table is going to make it clearer. H you already know is 0.1 in the whole in this question. And then this one is going to be like x3, y3. Okay, let me just substitute here. Then I'm going to write also the x3, y3 separately. Right, so what is x3? We saw that is 1.3. This one is not a problem. Then what is y3? Okay, is the same thing we got. Is this one here of the corrector? 7.054745. Y4 predictor. So, okay, we just need to do this one here. Okay. Okay, we're here, please. Okay, right, let's just do this one, please. All right, so it's 7.05. Okay, sometimes you can just get mixed up by the things you 0.1. Oops. Okay, 7 points. I'm just verifying with my calculator here. 0.054745, 0.054745 plus 0.1 times 1.3 times 7.054745, which is 7.97186.185. Okay, so you have this. You have exactly this here. Okay. All right, so you check these values there. All right, take note of these value. So this would be the value we most certainly get. Okay, I'm just cross-checking, please. I'm double-checking, please, to make sure that we're getting the correct answers here. 7.054 plus 0.1 times 1.3 times 7.05475. Okay, let's note this value here. Yes, that is the correct answer. That is most certainly the correct answer. Okay, note this value. Note this value here. Let's do the corrector. And then we shall tabulate all this. All right. Now, the corrector, we write down the formula first. It's easier because otherwise then you just get too many values a little bit and you get mixed up and you get swamped up. Right. So which means y plus 1 corrector is yi h over 2 f of xi yi plus xi plus 1 yi plus 1 right. So we're looking for y4, which is going to occur, excuse me. We're looking for y4 is going to occur when I is 3. When I is 3, so it's going to be 3 h over 2, which is going to be x3 y3 is x4 y4 okay. Now we have this. Okay, let's see. You already have all these y4 predictor and everything. Okay, can we just substitute? But yeah, let's just get some of the values like, okay, like this here. X4, Y4 predictor, what is it? X4 is 1.4. And then Y4 predictor is 7.97. 186. 185. So now what do we have? 1.4 by 7.97, 185. Okay, just a sec. 1.4, I'm just getting the product here. 1.4 by 7.97, 186, 185. Okay, so this works out is the correct answer. It works out to 11.160 659. Now, this is for this part. And then what is f of x3, y3? Did you get that one? Okay, let's just get it. F of x 3y3. Okay, obviously we need to multiply x3, y3. x3 is 1.3, like this. Okay, so yeah, just a sec. So it's 1.3, this one. And then we're getting y3. Y3 is exactly what we got. Right. So what did you have y3 to be? We had y3 to be 7 point this. That is our y3 that we used. Right, so it's 7 point, yeah? 7 point? Right, so the y3 is 7.054. 7.054745. And then 0. Okay, let's get the answer to this. Okay, we'll continue, please. Okay, so what is the answer here? 1.3 times 7.054745. 1.3 times 7.054745. And this is the same as what? Is 9.1711685. Okay, so we got this one, which is here. We got this one, which is here. H we know. Y3 we know because Y3 is this one here. 054745. So right, we are in business now. We got all these. So let's proceed. So which means we'll get the last value we need ever for this calculation, which is the answer to this at 1.4, which is the y4c is y3, just writing the formula, plus h over 2 into h over 2 into fx3y3, fx3y3 plus fx4y4p, fx4y4p. So, okay, y4p, c, excuse me, c is the correct now we're doing. Okay, right. So y3 is this one, which is 7.054. 7.054, 745. 0.1 out of 2. fx3y3, which is 9.17. Okay, we continue. Okay, yeah, we'll continue, please. Okay, we'll continue. Right, so, okay, we're continuing, please. We're finishing this question here. Okay, just get it away. 9 point, yeah, is this fx 3y3? Is it 9 point this? Yeah, 9.17, then 11685. 11685 plus. Then you have f of x4, which is this one. 11 point. Okay, we continue. Okay, we're still here. Right, what is this one? Is the fx4y4p. Just need to carry the, we just need to carry, it's 11.16, 11.160. Okay, how many 160s are there? It's like this repetition. There's 160, then 60, 659. So which means you have Y4C, $7.05474.5 plus 0.1 divided by 2 into 9.1711685 plus 11.16060 659, and then you compute. Right, it works out to 8.0713337.545. Okay, hence, this last value means that the 1.4 is approximated to be 8.0713337.545. Okay, so this is the answer in the question, or the answer to this question. But now there's a table that we'll draw. The table has two parts. So you have the what you call the predicted values. And you also have the corrected values. Right, so, and then you have x. X goes with 1, 1.1, 1.2, 1.3, and then 1.4. Like so. Let me just have the ruler, please. Otherwise, the table is just going to be so untidy. If then we have this, then you can draw here. And then you can draw another line here. And then you can draw another line here. And then you can draw another line here. Okay, I'm just going to be just plugging in the values here. We've already got everything, but just to organize the information, but also it helps us to see what we need to get. Because sometimes if it's just mixed up in the calculations, one can wonder what's happening there. But once it's tabulated, then you can see, okay, it's actually in some order. And then now we're gonna just quickly do the verticals and then we're done. Right, I'm trying to um, get all these values put here in the table. Right, okay, that's fair enough. So which means that you're gonna have this one here. Hello, my dear.
Because she's going to the clinic tomorrow.
Yeah, but yeah, but can you not fetch her in the morning, please? I just think it's better. What time is she supposed to be going to the clinic tomorrow? Okay, that's okay, that's fine. Okay, yeah, let me finish my class and then we're gonna sort it out. Okay. Yeah, I'll attend to you. Okay, thanks then. Right, so this is X, Y. My apologies, I had to take this call because this person has just been. Right, so this is X and that is Y, then that is Y predictor. And then after Y predictor, then we're gonna have a division like this. Let's see, X. Uh, this is Y, F, and then this. All right. Okay, you can have lots of these. Okay, just kidding. Okay, let me just complete the table and see what's missing. All right, because now we're going to have the x's, which are this. Then we have the y's, which are 5.5525. Then you have 6.22. Okay, all these were obtained before, but I've noted them down. So you have 7.054, then 7. Then you have 8.0713. And then you have f of xi, yi. And then this is 5. This is 6.1078. Okay, you can write it like this, but you can always jump. Okay, I'm going to explain why sometimes it can look as if the table is. You can jump and put some values in the middle of the table. Okay, I'm going to elaborate on that one. But yeah, this is much more compact. And then now you have 9.1711. This one is the predictor. These are the predictor values. And then these predictor values are always switched around. They're always switched around because this one is actually at x0, y0, x0, y0. And this is the fx0, y0. But this one is the y1. We make it to correspond with this for convenience, but you could put it here. But with that necessary understanding, compress this table like this: 1633, 6.975. I said this one is y1, but it's for a predictor, you understand. It goes with the x0, y0, but it gives a prediction at because it's a y1 value. It's a y1. So it's at the next, is here. If one gets, if we get what we actually mean there, but right. So this one is 7.9718, which is xi plus 1. All right. Now let's look at the xi plus 1 values. The xi plus 1 values would be, okay, also these ones now, they're switched around and you can, with enough space, whatever, I mean, but there's some understanding. Okay, this is xi plus 1, so it's ahead of these. This is like x0. So if this is x0, this one is like x1. So it corresponds with this, but we decide to put it there. 1.2 here, 1.3, 1.4. Next. So these values here in this direction are the predictor values, and these ones are the corrector values. And then here, this one is f of xi plus 1, then you have yi plus 1p. Then you have here yi plus 1 like this. So this is 6.05, 7.3959, 9.0675, 11.161. Okay, all these values were obtained before. And 5.5525, 6.2277, 7.05547. This one is 8.0713. Okay, so these are sort of the corrected values in the and the thing and the predicted values. Right, so I'm just gonna divide these quickly and then we're done. But we're done with this one, and then I'm gonna see how much time we're left with. I'm gonna give some exercises, which most of which I've done already, but I'll just check the time because that is essential. So yeah, we have this here. If you like, you can just remove this. Do a division and just divide this table into two parts that are symmetrical. And now the xi plus 1 for the corrector, and then you have the predictor as well. So predicted values, and then these ones are the corrected values. Like so. Right, with that said, then the conclusion therefore is y at 1.4 is approximately this value that sits here, 8.0 and 3. And that is what we got. So it's something to look at. So once you get these, there's no need to continue, because the continuation of these would be for the next value. But there's no point for us to be continuing because we've already got the answer. which is exactly what we want. But also a continuation of these is for the predictor again. And once you, because this we got for the from the corrector computation. So it is actually what we want. Okay, I'm gonna therefore give some exercises, lots of them. I'm gonna elaborate on these examples in my next appearance. Here is, I'm gonna call them exercises, like an exercise. So this one says, given dy dx equals x plus y, find the solution in the range 0, x 0.1 in steps of 0.05. Ish. Okay. Number 2, using the modified Euler's method, obtain okay, let me just respond to the student. Yes, Dumisa, how are you, Dumisa? Very well, thanks, Dumisa. I'm in class. Can I get back to you when I'm done? Okay, thanks, Dumisa. We'll talk. Okay. Okay, thanks, Dumisa. Goodbye, Dumisa. Thanks, goodbye. Mhm. Right, so using the modified Euler's method, obtain a solution of the differential equation, okay, of the differential equation dy dx, it's x plus the square root of y at 0 is 1 with step size h equals 0.2 is still number 2 in the range x element of 0, 0.4. Okay, number 3 exercise. Using modified Euler's method, find okay, Okay, using modified Euler's method, find y1. Right, find y1 for the, excuse me, find y1 for the, okay, welcome, welcome. I'll talk to you now for the equation. Right, for the equation dy dx, y minus x squared plus 1. I'm going to do these, please. Y at 2 equals 0.2 with step size. Right at this point, the step size is the h equals 0.2. Just note that is h equals 0.2. Okay, so these are the problems that you can try today, and then we'll do the corrections to these tomorrow, and then we shall do the exam as well of last year of November. The notion of the modified Euler's method will actually top the list for us, because it's extremely important for you to understand that. And so, right, I must thank you for obviously